Every programming language has this concept. So make sure you've listened to what I talked about in the book video, but we also create this, and it's similar to what we're going to talk about called an array. And we worked with arrays in pseudocode. An array was a way we could construct values into a single variable. So you're creating a list item. And so in this case, I'm going to make sure I have my information in there. So a tuple is very handy. And in this case, I'm just going to use inventory. And I'm going to say it's equal to, and I'm just going to use a open and close parenthesis. And that tells Python that, hey, you're not creating a variable with a single value. You're creating a variable with multiple values, or the ability to store multiple values. Well, this can be very, very handy. I can store multiple items inside of there. Every other programming language almost requires me to set up here, and it says I'm going to create an array. It's going to have X number of boxes. Those boxes are going to be of this specific size. Python says, you know what? Go ahead and add as many items as you want. I'll take care of the details for you. So if I'm doing this in C++, I've got to create how many boxes I use, what kind of storage they are. This, I said inventory. Do we know if it's a number or a letter or anything at this point? We don't. We don't know any of that. So we can put in values in there. So we could say inventory equals, and notice I use that parenthesis again, and I'm going to put them in as text items. So the book goes into this whole thing about swords and kind of a medieval thing. I'm going to create an inventory of flood survival items. So it would be number 1 on our flood survival item. Water. Kind of ironic, the water comes in and we'd lose our ability to have fresh water. What else would we need in our inventory? Sewer. Kind of the opposite of water. So, food. So, all right, and I'm going to close that. And so now, the other thing I can do, and honestly Python doesn't care, is I can break this down line by line to make it easier to see. So I have now added 1, 2, 3, 4, 5 items to this. And let's just see what happens if I print inventory. So we're going to run this program really, really quickly. I'm going to run module. I'm going to call this inventory, wherever I'm throwing it at. So when I run that, it comes back and it says, hey, water, sewer, food, shelter, clothing. Ooh. Well, that's pretty handy, because I printed that entire inventory by calling it one time. So we can also do something where I print an item, a specific item in that inventory. So I can print out the entire inventory. I can actually reference a specific item inside of that. How do you think I might reference those specific items in there? So I can do a really quick way. So let me show you one thing we can do here. So I can print the entire inventory. I can use a for loop that does something interesting. And this for loop says, hey, for item in inventory. So this translates each piece into a piece of that inventory. And so now if I ran this, so it did print that inventory in this model, but it also printed it this way. And printing it this way, it says, oh, each one of those is an individual thing. So it translated item temporarily in that loop each time through there and pulled item that's in index 0, index 1, index 2, index 3, index 4. So we have 5 items, but those are all referenced by an index value. So what happens if I just do this? What happens if I just do a print? And let me just take this out for now. And I want to print the third item in there, food. Can I print inventory? What happens if I do this? Where I try to reference that specific item. Do you think it's going to work? Well, let's see what happens. And oh no. It says tuple object is not callable. No. So we may have to do a little work on figuring out how we get an individual item out. What happens if I said item equals inventory 3, and then I print the item? Is that going to work? ITEM, not if I don't spell right. It won't certainly do anything. And so it keeps telling me that it's not a callable item. So we're going to have to work on figuring out how we can get those inventory pieces to work. So we have a couple of steps we need to take here. And so we'll show you a couple of those pieces. There is one other thing our book talks a lot about that's kind of interesting, I think. So because Python really loves us, Python allows us to do a couple of other things. So Python gives us the ability to search through an inventory or a tuple or a list or an array, whatever we want to call it at this point. And it allows us to search through that list with one line. So using if not inventory, in other words, if nothing exists in inventory, it gives us that ability to search that and see if it's empty. We could do it in other languages, but we have a lot more steps to it. In this case, what have I left open? Something in there. So in this case, what it would do is it's going to run and check that inventory and says if it's not empty, it's going to print this. Or if it is empty, using the not, it's going to say you're empty-handed. So we put all that together, and we end up with this heroes inventory, if you look at that one through your book. And that hero inventory, no, cancel, I'm going to leave that one open. We'll show you a couple of things. So we have moved over. So this one actually does do the sword, the whole thing. So if I run this particular guy, it first says you're empty-handed. And we actually use that same technique we did at the end of the program here to hold it open to wait for you. Now we put in the sword, armor, shield, healing potion, or we put in the water, sewer, those kinds of things. We put them into that inventory, and then we printed them out one at a time also. So we did both techniques there. So make sure you've worked through that one. We're going to expand this program just a little bit. And we're going to have an inventory 2. So we're going to have some very similar things. So I am going to delete there. So we start out with inventory. It's empty. We know it's empty. We put items in there. And so we might want to put in a little different ones. We might want to put our water we might want to put in food. We might want to put in clothing, whatever it is we have in there. And I think the other one we had was shelter, maybe. So we can put in a list of our items. And so now we've got an inventory built up. And so we know we could use the for item in inventory, and we could do that. So for item in inventory, print item. So we know we could do that, and it's going to print out our list of items. So we're going to try that. Yep, we're going to save it. And it's first going to say, hey, you're empty. Hard to move around. These things are so big now. Drop that one. Do I want to save? No. All right. So where is my print model? There it is. All right. So it says, hey, you're empty-handed. And I say, okay. But I'm going to hit the enter key to continue. And then it says, hey, we have water, food, clothing, and shelter. So now we've got some pieces in there in our inventory. So we've created a list. It's got pieces in there. We want to manipulate it. And we want to start looking at how we actually do some of these things. So let's do one thing really quickly. Let's see if we can tell how many items there are in our inventory. Okay. So really quickly we could do a print statement. Print, you have, and we get a new command called a length. And length we shorten to len, and notice it becomes a key phrase there. So we're going to put inventory in there. And so now length is a numeric value for us. And so now, hopefully, if I can see it on the other screen, it's going to tell me how many items I have in my inventory. And let me see if I can manipulate this size a little bit. I don't want to do that. I'd like to get down to the bottom and shorten it a little bit, but I don't seem to have the ability to do that. So we're empty-handed. Oh, I spelled inventory wrong. Inventory. Helps if you spell right. All right, so drag that over so we can see it. You're empty-handed before we put anything in there. Now we add water, clothing, food, shelter, and we have 4 items to survive. Well, that's kind of a handy thing to do. We know how long that inventory piece is. So if I want to look at one particular item in there, we're going to do a little bit of a cheating, and we're going to create something of value. And we're going to call it index, because that's what we generally use. And we're going to set it equal to an input. Please enter what index you want. Now, there's already one problem with this I can see right away. When you get an input, it's always a text string. And normally I'd make you go through and figure out why. But we know that everything we input is a text string. So if I want to get a numeric value, I have to translate that from string to either a decimal or an integer. In this case, we really want an integer. And now we're going to print at index value. And we're just going to say what that index value is. Your survival item is, and then we'll say inventory. Now, instead of, and I know this is where it seems a little weird, so instead of using the parentheses, which is how we created that, we actually are going to use a different bracket. And so that bracket we're going to use is the square bracket right above the shift key if you look up, the square one, and we're going to put index in. So we're going to allow you to type in a value, and that's what's going to be used. All right, now I have to end my print statement. And so now if I hit F5 and if I manage to type everything correctly, no guarantees, I'm going to press the enter to continue. Water, food, clothing, shelter, you have 4 items. Please enter what index you want. And I'm going to index 3. And it says at index value 3, your survival item is shelter, which I think is correct. But here's the problem. When I look at this list, shelter is our 4th item in the list, right? Because we start by zeros. So I would have to change that a little bit just because if I'm counting so people would have the same idea, right? So we know we'd have to change that by 1. So not a big deal there. But what I want to see what happens if I run this? What index do you want? And I put 6. Do we have a 6th item in there? And it's going to fail pretty quickly. So we do have to be careful. And one of the things we'll show you fairly quickly is we can sanitize those inputs so that they're correct. All right, let me close this, minimize that. So you do have to be a little careful of, and one of the things you can do is you can bind that. You could use that link statement, and then you could actually error check your input right there. So there's some other things we can do with lists and tuples that are kind of cool. And so I want to actually do something really interesting. I want to put 2 of them together. So I'm going to create another one. And because it's handy and it's hiding over here, I am going to grab part of the heroes inventory, and I'm just going to throw it in my program. So paste, scroll down a little bit. So I'm going to put in another inventory item. And I put in chest, just because it's got gold and gems. And I am going to add those 2 together. So I'm going to say inventory. If I can spell inventory today, which is not likely, equals. I'm going to say inventory plus chest. So just like we can add numbers, we're going to see if we add those 2 together. And then I'm just going to do a real quick print. My indent's not right. Print inventory. I know this isn't the prettiest, but I'm going to want to cover a lot of material fairly quickly. So I'm going to print inventory. So let's see what happens. So you're empty-handed. Oh, now we have water, food, clothing, shelter. What index do I want? I want 2. It prints it out. And then now look at this. It prints water, food, clothing, shelter, gold, and gems. We just added those two tuples together. So it's a handy way we can create new and bigger units. So that is kind of a handy technique. So there's also some other things we're going to talk about where we can slice and dice and cut things apart. So we will show you those in another piece here. So I'm going to leave that out of my way here. So this is a great way I can store items. I can store items easily, and I can use this index to reference items. So I'm going to change this just a little bit. I'm going to take out some of this content. This I'm going to leave up so you can see it for a minute. I'm going to take this out. And I'm going to create an inventory, and we can let it print. That doesn't matter. And you can have how many items. I am going to take out this temporarily. And I'm going to print and create another inventory list. So in this case, I'm going to create one called price. So what I am doing is something called parallel arrays or parallel tuples. So what I am doing is I'm creating a list of prices. And so I'm going to say water is 5. So I'm just going to put them on new lines so it makes sense. Food is 15. Clothing is 100. And shelter is, let's say, $1,000. We're just throwing out some numbers. And so now I've actually created another list. So copy. So I'm going to print out this one also, just so we can see that it does work the same. And let's see what happens. What did I do there? Oh, that needs to go backwards. My bad. All right, back. There we go. All right, so it says I have water, food, clothing, shelter, and I have 5, 15, 100, 1,000. And you have 4 items to survive. All right, so it does indeed print out 2 items. And so we have this parallel array. So what this gives us then is if I say I want a particular item, so maybe I say enter your item for, pop this open so I can just copy and paste really quickly here. So maybe I want to grab an inventory item for and allow you to do it. So the index number for an item in inventory at index is this, right? So I'm going to run it. And it says, I'm going to put in for number 2. So right now it says clothing, and I have 4 items to survive. So it's got our link, and I can access one individual item. So now, with that idea of parallel arrays, I can also then say, print the cost for your item is price So I use that same index you told me, and now I reference, so if I reference 1, I reference price 5. So let's see if that works. So I want to index for an item in there 2, and it says at index 2, it's clothing, the cost for your item is $100. So we can put these things together. So think about how many different things we use like this. If I reference your student ID, I could create a table of classes. I could create a table of grades. And by using that index value, I can then put those 2 pieces together. And so it's a really great way that I can make pairs of things that will work very nicely. So your assignment this week So you're going to have to go through my video so you can see how some of this works. So I go in great detail about this. But what you see is, in the very first line over here, let me see if I can make this bigger. Options. Configure. Let's go to 25. Apply. There we go. All right. So this is the word jumble game. Very first thing it does at the top, we import random. Okay. This section says we're going to create this list of words. So that's that tuple, just like we've created before. Because we're not changing it in any way, notice we called it words, so we know that it stands as a constant. Now, quite frankly, that's just an arbitrary thing on our part. Python could care less. But we create this and we have words and we have a list of those words. So Python, jumble, easy, difficult, answer, and xylophone. So this program, what it does is picks a random word out of that. So we have this really handy thing called random.choice. This takes out about 15 lines of code. We could do it randomly. So we could find out the length of this. We could then do a random range from 0 to that length and pick a number and then access it that way. This very handily says it picks a word automatically for us out of there. Pretty handy tool. And what it later does then, so it takes this word, whichever one of those it grabs, and it jumbles up that word. And so what it's doing here is kind of interesting, and I will let you have to go through the video, my little force to get you through there. How this jumble works is kind of interesting. So we start the game and we print the jumbled version of the word. We guess, and it says, all right, while I'm guessing is not correct, and the guess is not blank. So in other words, if you put in a blank, it's also going to say, nope, that's not it. So if guess is correct, and it says, hey, you guessed it. Print, thanks for playing. So let's run this, see what it looks like. So it says, hey, your jumble is LEMJUB, whatever it is. All right, so I'm going to type in gem because, you know, I'm not real bright always. But I accidentally hit the enter key before I did that, so I killed it. So let me restart that again. So the jumble is something. So I'm going to type hop. And until I hit that enter key, the program will loop over and over again. So if I look at that, that's not a giant game, and it's kind of an interesting sequence. So while guess is not correct and guess it does not equal that blank, sorry, that's not it, and it loops again. Input your guess. So not a lot to this program, and it's very scalable. If I want to add another word, so I put in Peru, do it lowercase just so it's easier to deal with. And I wanted to put in flood. And I want to put in any other set of words I want to put in there. Let's do Nebraska. So any of those words I can do that. And so I'm going to save it and run it again just to see what happens. Your jumble is, so what is that one jumbled out or unjumbled? So let's do one more thing to check. What if I put a capital A in there? Do you think it's going to work correctly? Sorry, that's not it. So we can already do a couple of things to make this a little better. Last week, a lot of us figured out the upper conversion, so we could take their input and we could do this to it. So we could say guess equals how would we set that up with the upper, just so whatever they input would be lowercase? So guess dot lower, and whatever they type in will convert to all lowercase. Now, the problem is we need to do it 2 places, right? So that's our priming the pump input. So we also need to do it here. So now we can try it. So what is FOOLD unscrambled? Nah. So let's try it. Let's type flood. And it guessed it. So that's a really great little improvement we all made to our program right away. So the next improvement that it says is, hey, you need a scoring system and a way to give a hint. So one way to give a hint, so we have all these words up here. And inside of this link, so we know that they've guessed it once by the time they get to the bottom of this, right? So we could say input, do you want a hint? Now we need to assign that a variable, so let's call it hint. And you can go through, we've had code about doing yes, no's. So I'm not going to get a lot of the coding there. You guys can go in and put that in that we've already dealt with. So do we want a hint? Yes, no. If hint equals, and so you'd probably want to do the lowercase, and you should be able to manipulate strings to take just the first character at this point. So we can make a robust hint. If hint equals yes, well, now we got to figure out how to give a hint to each one of those words, right? So this is one method, and I'll show you a problem with it. So we could put inside of there if, and notice up here we get the correct equals word, right? So if correct equals, let's look at our list of words, Python. Print sneaky snake. And so I could go through and I could do L if correct equals, what's our next word in our list? Jumble. If elf equal jumble, print scrambled. And I could do that, but there's a couple of problems with that. So is that very scalable? Is there a better way to do that? Probably. So I went through a whole lot describing something about using 2 structures where we use a similar index. Is there a way to do that? So this would work, but it's not scalable. If I had 100 words in there, would this get ugly? Yeah. So I gave you a hint about creating a parallel array, and I think that would probably be the easiest way to create hints. So could you create an array of hints that would work the same as we did on that price in the inventory? So You still would probably want this portion, but instead of doing this, you would then have a call to that parallel array, print out your hint, and you might be able to come up with a way to create a hint function inside of that. The next thing you're supposed to do is create a scoring system. So I'm going to eliminate that. Is there any way to keep track of how many times they guess a word? So could we use a counter? Probably. So at the beginning of this, we probably need to set counter equal to 0. And you could put a counter in and so you could keep track of how many times they guessed. Now, you want to follow the logic a little bit on here, because right now, if I came out here and I could put a print statement in right here, print, you guessed it in counter. So that doesn't look that hard to do. But let's see what happens if we run this. Make sure I haven't done anything. So my guess, rupee, Sloopy, Argentina, Peru. So how many times did I guess that really? Is that 4? Oh. So why does our logic say that it guessed it in 3 times? Yeah. So is there an easy way to fix that? So we could just say counter plus 1. And now, in theory, you guessed it in 4 times. So there's other ways you could create a scoring system. So you could then take that and give them a category. Do like an if statement and say, if counter is less than 5 times, congratulate and say you're a master. If greater than 5 times, say, man, you're really slow. It took you forever to guess this. So you could do all kinds of things like that with it. So that's what I'm looking. We have an existing program, and you can grab that out of the book. There is a download file on the website that you can grab. And so you could put in all different kinds of things to make this program snarky if you wanted to. So you could do if counter greater than 5, print, well, you guessed it, but it took more tries than, make up whatever snarky sentence you want to have in there. And then you could even do an LF, or you could, so you could do an else. So, and you could break it down into all different kinds of categories. One of the things you generally want to do when you do an if and an else statement, especially if you're using a bunch of elifs, is you use that else as a safety valve. So this one has one of 2 possibilities. But if were listing them in ranges, I would probably do a safety valve at the bottom here where that else to make sure that it would work correctly. So this would just say if they get it over 5 or lower than 5. And so you could do all kinds of things with that on a scoring system. You could give them, so one of the other things you could do is you could even put in a third and statement and counter less than 10. What that would do is that would exit you out then if you didn't do it within 10 turns. So we can try that. Well, you guessed it. So you'd have to change your if statement down there a little bit to fix that, but so you could add those kinds of things to make it more challenging. So in that case, your counter, you're counting up to 10 times. You could even do it or as long as counter is greater than 1 and do a countdown. So you can do all different methods to do that. In this case, if you're going to keep something like that, I would change my if statements here to reflect if it's equal to that 10, well, you lost because you're not able to do this, and then have your other statements in there. So you want to make sure it's consistent however you do it. So I'm just showing you a lot of different ways to do it. So the hardest piece is probably the parallel array, if you want to use that as a hint function, which I would strongly encourage as a way to do that. And the advantage to that, it doesn't automatically generate a hint, but you can have a hint specific to each one. I have had students even make multiple layers of hints. So they had hints 1, hints 2, hints 3, and so they could ask for a hint multiple times and do that. I have had students do very clever hints where they've went back in and using the slice, they've taken out like the first or third letter and said, the 5th letter of your word is F or something, and you can do that. So there's lots of different ways to do that. I have had students transform this where it asks if you want to play again. So in other words, you put the entire main of the program into some kind of a loop, just like we did last week. So what you do with it is up to you to change it. But what I am looking for is, do you have a well-constructed hint section of some sort? Or do you have some form of a scoring system that works and works effectively? So this I think, is a little different. You have to change an existing program. So you know it runs when you start. Don't break it as you're putting it together. All right. So the other piece for this week. So you have an assignment over here.